Let's look at problems involving compound probability. Before we start, I want to look at two kinds of compound probability. The first is independent events, events that don't affect one another. So the probability of A and then B is the probability of A times the probability of B. That's for independent events. And then the probability of dependent events is the probability of A, then B, is the probability of A times the probability of B after A. And we'll look at some examples in the resulting in the questions on these sheets. So first one is a small software company has 3 customer service representatives. After a week of observation, the supervisor of the customer service department determines that there is an 85% probability that a customer service representative will be on the phone with a customer at any given time. What is the probability of all 3 representatives being on the phone at the same time? Well, that's the same as the probability of A and B and C, where A, B, and C are the probability of each representative being on the phone at any given time. So that's the probability of A times the probability of B times the probability of C. Well, each one is 85%, which can be written as a decimal, 0.85 times 0.85 times 0.85. When we multiply those together, we get 0.614125, which rounds off to 0.61, and that equals 61%, or B. In the second problem, in a word game, you choose a tile from a bag, replace it, and then choose another. That's significant because that makes it independent probability. If there are 21 vowels and 15 consonants, what is the probability that you will choose a consonant and then a vowel? So that's P of C and A, and V, where P of C is a probability of choosing a consonant. So that is probability of choosing a consonant times probability of choosing a vowel. Well, the probability of choosing a consonant is 15 consonants and a total of 15 plus 21, or 36 letters. And the probability of choosing a vowel is 21 over 36. When we multiply those together and simplify them, we get 35 over 144, which is C. Okay. Now the question involves dependent probability, and we'll see how that works. So you have 3 $1 bills, 4 $5 bills, and 2 $10 bills. That's 3 plus 4 plus 2, or 9 bills altogether. You select the bill at random. Without replacing the bill, you choose a second bill at random. Find the probability of choosing a $10 bill and then choosing a $1 bill. So the probability of choosing a $10 bill and then a $1 bill. So that is the probability of choosing a $10 bill times the probability of choosing a $1 bill after the $10 bill. Well, probability of choosing a $10 bill is there are two $10 bills and there are 9 bills altogether. So it's 2/9. Now there are only 8 bills left because you are not replacing it. You're not putting it back into the wallet. So there are 8 bills left, but there are still 3 $1 bills. So it's 2/9 times 3/8, which is 6/72, or 1/12, which is A. Okay, this problem involves figuring out what a probability is going to be after we do a couple of turns. So here's the problem. Thomas, Jenna, and Maria are playing a game. They have a bag that contains 42 white tiles and 4 red tiles. Each player takes turns picking a tile at random and does not return the tiles to the bag. So that's dependent probability. The player who draws a red tile first is the winner. In the first round, Thomas goes first, Jenna goes second, Maria goes third, and none of them gets a white tile. A red tile, I'm sorry. What is the probability that Thomas will win the game on his second turn? So his first probability is the total number is 4 red tiles and 42 white tiles. So at the beginning we have 46 tiles. The probability of getting a red tile is 4 out of 46. Doesn't come to pass. So then there are 45 tiles left in total and still 4 red tiles. Again, doesn't happen. Then we have 4 out of 44 for Maria. Still, a red tile is not picked. So we're left with 4 out of 43. And that's B. Okay. Suppose you choose a marble from a bag containing 2 red marbles, 5 white marbles, and 3 blue marbles. 2 plus 5 plus 3 is 10 total marbles, 10 marbles. You return the first marble to the bag and then choose again. That makes it independent probability. So we have P of red and blue. We have P of red times P of blue. P of red equals 2 out of 10. And P of blue equals 3 out of 10. So this comes to multiply this across, we get 6 over 100, or 3 out of 50. And that's answer D. Okay. A basket contains 11 pieces of fruit, 5 oranges and 4 apples, 5 oranges, and 2 bananas. Jonas takes a piece of fruit at random from the basket, and then Beth takes a piece of fruit at random from the basket. What is the probability that Jonas will get an orange and Beth will get an apple? So that's the probability of orange than apple. And this is dependent probability because you're not going to put the fruit back in the basket after you've taken a bite. So probability of orange is multiplied times probability of apple after orange. Probability of orange is 5 out of 11. Probability of apple is 4 out of 10. Multiply that, we get 20 over 110, or 2 over 11, which is answer number D. 7. If A and B are independent events, and P of A and P of B are both greater than 1/2, then P of A and B is sometimes, always, or never greater than 1. Well, we don't even care about all the rest of the information. All we need to look at is this. Is this ever a true statement? Is P of A and B ever greater than 1? Well, for probability, our fraction is favorable over total. So the largest that could ever be is if your favorable was your total. So this is less than or equal to total over total. Since these would be the same number, that would cancel to 1. So the probability of any event has to be less than or equal to 1. Therefore, the probability of A and B is never greater than 1, because 1 is certainty. 1 is the highest probability that you can have. And the last one, you toss a coin and roll a number cube. Find P of heads and an even number. This is independent probability, P of H and even. Well, P of H times P of even. P of H is 1/2, or 1 out of 2. P of even is 3 out of 6, which is also equal to 1/2. When we multiply those, we get 1/4, which is letter B.